What up, everyone? Our planet is a so unique place to live in, and we know how small we are comparing to other galaxies or the universe. But we mostly all know just how Earth could have become to be. But what about the universe? Have you ever wondered about how our universe was born? In today's video, we are going to talk about a particular theory, the Big Bang Theory, and we will explain you how the universe was born according to this one. Of course, there are other theories as well, as we are not sure about them.
We can kill a light, hit the light, let it black out, hit the light, let it black out.
Before we get into this amazing history, I like to mention the fact that this video was mostly based on this particular book. I highly recommend reading it as it tries to explain astrophysics in a digestible way. And now let's go back in time to the starting point, 14 billion years ago. So, scientists were about to discover the fact that our universe is constantly growing. And with enough observation and exploration, they were sure about us. But if the universe is constantly growing, it means it must have had a starting point, right? So at the beginning, all matter of the universe was in one little point, which we call singularity. Wait, what? Singularity is something that is really hard to describe as it's unknown for scientists too. It's actually an infinite gravitational force in space-time. We know space-time, right? I mean, it can be familiar from movies and series. We've known it since Albert Einstein, who explains that space and time are not two separate things. It's like the x and y axis of a function. If you go forward in space, you will go forward in time too. But let's head back to singularity. Singularity can be found in black holes, but we cannot observe them either. So basically, singularity will be the unknown existing thing. And at this time of the universe, everything was in one subatomic particle, where our basic principalities weren't true. Our first period is the Planck epoch, when time was smaller than t equals 10 to the power of minus 43, and at this era the universe hasn't even reached 10 to the power of minus 35 meter in diameters. At this stage, the universe was incredibly, or actually infinitely hot, and our fundamental forces were combined in one. These were the electromagnetic force, weak nuclear force, strong nuclear force, and gravitational force. This era is very debatable, not just because we can't actually absorb it, but also because our main physical laws cannot work without separation of the four forces. However, everything changed when the gravitational force separated, or at least that's what scientists assume. And this can be described by our gravitational theory. Also, the universe continued growing, and the strong and the weak nuclear forces were apart. At this point, the universe was more like a hot soup of leptons and quarks and anti-leptons and anti-quarks. Basically, anti-leptons and anti-quarks instantaneously annihilated leptons and quarks. What are quarks and leptons exactly? So leptons are elementary particles which cannot be separated to smaller parts as far as we know, and they don't participate in strong interactions. For example, electrons are leptons. Quarks are elementary particles too, from which protons and neutrons are built up. There are 6 types of them: up, down, strange charm, top and bottom quark. They can never be found alone. Lastly, the weak nuclear force separated from the electromagnetic force. The weak nuclear force controls the radioactive decay. The strong nuclear force keeps the nucleus together, while the electromagnetic force keeps molecules together, and gravitational force is responsible for holding together anything big, basically. At this state, the universe was hot enough for the same happening going on with photons as with quarks and leptons. So photons and antiphotons created permanent couples, which also annihilate each other. This is proven by Einstein's theory of general relativity, because E equals mc to the square, and this works from the contrary points too. And now we enter into the quark-lepton era. Quarks are never alone, as I explained earlier. However, they can separate from each other. And that's what happened in this era actually. The imaginary line which connects quarks constantaneously split up and was formed. This again can be explained by E equals mc to the square. Scientists also assume that at the very early age of the universe, there was a time when it was asymmetric. And this is gonna be important. As a result of that, there was 1 billion and 1 to 1 billion chance that normal particle beats up antiparticle. This small chance goes later in our galaxies, planets, stars, everything. But don't rush into this. First, when the universe cooled down, hadrons appeared and they went through the same process as quarks did. Hadrons built up from quarks, and the two well-known hadrons are actually protons and neutrons. This was the time when electrons had to go through the same process as quarks and hadrons did. So, basically, electrons and positrons, which are anti-electrons, constantly annihilated each other until it got out of this loop with the same rate as hadrons did. This is how every proton got one electron. As cooling continued, under 100 million Kelvin, protons and neutrons could form nucleus, and other heavy materials could appear too. The universe consisted of 90% of hydrogen, 10% of helium, deuterium, and tritium. And now we're going to speed the time a little bit up, as 380,000 years went behind us. Until the universe cooled under 3000 Kelvin, electrons could move between photons. However, this stopped, and every electron settled down with one nucleus. This is an end of a huge era, when particles and atoms formed in the early age of the universe. Gravitational forces are able to drag galaxies together, and more than 100 million galaxies were born, and more than 100 million stars appeared per galaxy. This is amazing, and stars were able to make heavier materials than hydrogen because they are dense and hot enough. Later on, these made up the planets. After 9 billion years, we can check out a not so important place of the universe, the Virgo supercluster, and that had a not so special galaxy in it, the Milky Way, which had a little part, the Orion arm, where a new star appeared, the Sun. The possibilities were provided for planet formation, and it happened with colliding rocks. First, because of the too fast meetings, any kind of molecule formation was impossible. However, with disappearing rocks, molecules could form and they could cool down. So, at a very lucky place, planet Earth was born. It was in the habitable zone of the Sun. I can just say that the rest is history. If you enjoyed this video, and if you found it interesting how the universe was born, then hit us a like or subscribe. And honestly, a share would be amazing. You can also follow us on TikTok, Facebook, Instagram. And as usual, see ya after the blackout.